In this video, I want to discuss how to approach a problem like this, and in the process, illustrate how to determine conversion factors from the metric system, as well as dimensional analysis for these types of calculations. One thing to notice here, we're talking about distances, okay? And so with practice, you can look at these different prefixes and get a feel for what's longest to shortest. But more generally, what you do is you take each one of these measurements and you convert them to some common unit. Usually what's done is it was recommended to convert it to the base unit. In this case, we'd want to convert everything to meters. Now, since we're going from a unit with the metric prefix to the base unit, there's just going to be one step in the dimensional analysis. So you really just need one conversion factor for each one of the calculations. So in no particular order, let's just go ahead and deal with this value here for megameters. Notice there is a capital M, lowercase m, and another lowercase m. So meters is always going to be lowercase m, and it's going to be on the right hand side. And then whether it's lowercase m or uppercase m distinguishes between mega and milli. So something dealing with a large measurement versus a small measurement. Now let's just take this example and then work it through for dimensional analysis. Now this is a fairly typical table that you see for the metric system. You're given the symbol and then you're given the power or meaning. Sometimes it's referred to as meaning. And you actually use this information to generate a conversion factor. And the conversion factor is going to relate to the base unit to then the unit of interest here. And to generate this conversion factor, I think probably the best place to start is actually with the symbol itself. And say something like this. Well, if I'm talking about 1 megameter, how much does that equal in terms of just 1 meter? Or not 1 meter, but the unit of meters. And what you're going to do here is take the power, the symbol, and just say, well, what does it represent? It represents 10 to the 6 or a million of something. So instead of writing the capital M in this place, what you do is you use this power and just change the capital M to its symbol in the context of like scientific notation here. This is going to be your conversion factor now. So then if I want to do a dimensional analysis calculation, right, I start with what's given, always do that. I'm going to include all my units here so I can keep track of, what I need to multiply by, what I need to divide by. And now this conversion factor, this tells me that you have 1 megameter. Since I'm starting with megameter, it's this portion of the conversion factor that I want to put on the bottom. And then the other portion is going to go up top. Once I have the expression set up, then it's just the math that I have to work through, right? So for our dimensional analysis setup, think of this as like a mathematical template. It keeps track of what you want to multiply by and then what you want to divide by. Now in this particular example, some number divided by 1 doesn't change it numerically, but one thing that it does do is it cancels out the unit that I'm starting with here. And then this is going to be like my scaling factor. If I plug this in the calculator, what I get, 8.3 times 10 to the minus 4 meters. So now what I'm saying is that this value here is equal to that value. We're just using two different unit measurements to express the same value. And now what I want to do is do the same thing for the other 3 distances in my list here. Once I have them all converted to meters, then I can just look at the numerical value and say, well, this one's longer and that one's shorter. And then I can lay out the expression here. Let me do one more. Let me do the 12 centimeters. So what does centi mean? Well, centi means 1/100th of something. And just like I did before, first thing I'm going to do is figure out my conversion factor. So again, if I start with the unit with the prefix, if I say, well, what does 1 centimeter equal to in the context of meters? Well, again, just like I did before, I simply take my prefix and then I insert this power in this portion of the expression. That's it, right? The centi, is equal to this factor, to this power. This is my conversion factor. Now I'm ready to do the calculation. Just like before, I start with what's given, 12 centimeters. I have one step in my calculation, so I have one of these mathematical templates. The portion that goes in the bottom, well, it's the unit that matches up. The other portion is going to go on top. Now if I do the math here, well, let's just show that, right? Multiply, divide. That's always the case. Anything on top you multiply by, anything on the bottom you divide by. Now this 10 to the minus 2, effectively what it's doing is moving the decimal 2 places to the left. That's another way to think about these calculations. So this is 0.12 meters. So at this point, if I just sort of insert these two values are equal to each other, and then from the first calculation, I know these two values are the same. And I'm starting to see that now, okay, this distance is longer than that distance, right? As the exponent goes into the negative side of things, you're getting to a smaller and smaller value, right? Because another way to write this portion, you could have written it this way as well. Right? I'm moving the decimal over one place to make it scientific notation. It's not required here, but it does change the exponent or give you an exponent here to compare with the exponent there. Now at this point, what I would encourage you to do is pause the video, try to do the same calculations for these two, and then start the video, and then I'll show you the answers in just a second. Okay, so here are the answers. What I've done here, I've included the conversion factors on the bottom, and then I've included the final distance in meters on top. And so what we can see is this one is originally one that was expressed in millimeters is actually the longest distance, 610 meters, followed by this one, then the 12 centimeters, and then finally the megameters at the end. Okay, I hope this was useful.